Assalamualaikum and a very good morning to Madam Zafika. Today our group will present about Earthwork. So this is our team for this group. There are four members. The first one is Muhammad Khalid bin Yahya, which is myself. The second one is Yun Hilda Juspat. Next is Thompson Jeffrey Edward, and the last one would be Leonardo Jacob Anak Jr. For the purpose of the report is to study on earthworks based on two completed projects in Sabah. These projects were selected by our group due to the relevance, scale, and distinct of construction features that can offering valuable into modern excavation and geotechnical practices. The main objective for the one the main objective for this report is to do an comparisons between characteristic of soil, problems and solutions that have been faced and taken, and uh, construction technique. What is earthwork? Earthwork is the work that involves with digging, moving, and compacting soil and rock to prepare the ground before build anything. The tasks include clearing site, excavation, cut and fill, and compacting the soil. Earthwork also is a crucial part because it can help to strengthen the ground to support buildings, prevent settlement and structural failure, and it is also can improve drainage and reduce erosion. For the important part is it can ensure the safety of the occupants on the building. The first project that I will presenting menaik taraf Jambatan Sungai Noyok, Stesen Perikanan Babagon, Kampung Tipango, Kampung Lotong Penampang. For this project was carried out by Bisa Juta Sdn Bhd. The contract value for this project is RM 16.8 millions with a 24 months construction period. This project was officially started on 10 July 2022 and successfully completed on 9 July 2024. This project was part of the government initiative which to improve rural infrastructure in Penampang, aiming to stimulate the economic activity in region. The primary objective was to upgrade and enhance existing bridge crossing Sungai Moyok, which plays a vital role in connecting Station Perikanan Babagon with the nearby villages of Kampung Tipango and Kampung Lotong. So these are two organization chart that we can see. The first one will be JKR organization chart on the left, and on the right is site organization chart. Now, let's look at the geotechnical conditions at the project site for the menaik taraf Jambatan Sungai Moyok, Stesen Perikanan Babagon, Kampung Tipango, and Kampung Lotong Penampang. So, as we can see, the perimeter around the project site is primarily composed of alluvial soil, which is typical of floodplain areas along rivers such as Sungai Moyok. These soil are generally a mix of silty clay, sandy loam, and these types of soil are known to have moderate to low shear strength, susceptibility to erosion and settlement, especially when water saturation is high. For the engineering challenges, due to this characteristic, soil type presents geotechnical challenges, particularly when the site is exposed to heavy structural loads, and the second one is seasonal or constant high moisture content. For the geological context, according to the Geological Survey of Malaysia (JMG 2017), Penampang is classified under the Quaternary alluvium zone. This means the ground here consists of unconsolidated sediments, including clay, silt, sand, and gravel. For the required soil improvement measure, given this soil condition, the project soil improvement practice need to cover, for example, deep piling to reach more stable load bearing layers. And the next one is compaction methods. It can help to improve surface soil strength and reduce settlement risk. So for the next slide is scope and magnitude of earthwork operations. In this part of the presentation, I will explain the type and extent of earthwork activities involved in the menaik taraf Jembatan Sungai Moyok, Stesen Perikanan Babagon, Kampung Tipango, Kampung Lotong, Penampang Project. So, this project requires significant earthwork operations due to the flood-prone nature of the area and the existing topography. The major earthwork activities include site clearing, heavy excavation, grading, and construction embankments. For the excavation and backfilling, excavation involves removing unsuitable materials such as soft alluvial soils, vegetation, and organic matter. For the backfilling, it will cover with compacted to meet required design strength and rest to the correct elevation for the bridge foundation and approach rods. For the site challenges and soil stabilization, given the high water table and the potential for seasonal flooding, enhancing the load bearing capacity and drainage around the site is crucial. To tackle the variable soil profile, additional measures may need to do to propose a soil replacement, mechanical stabilization using crushed aggregates or geotextile. For the determining the scope of earthwork, the extent of earthwork will be finalized based on detail on topographical surveys. However, preliminary estimates indicate a moderate to high level of terrain reworking will be required to achieve the desired stability and elevation. For the earthwork standards and specification, all compaction activities must follow with the specific requirements like design strength, optimum moisture content, and material quality. This must comply with the Public Works Department Malaysia JKR standard specification for roadworks JKR SPJ 2008. For the importance of proper earthwork, proper execution of earthwork is critical because of it can helps to ensure the structural integrity of the bridge, the safety of user, and the resilience of surrounding communities. Next, I will present about the types of heavy specialized equipment that have been used in this project. Why is equipment and tools are very important? So, several key machines will be mobilized for site clearing, excavation, and material handling. For example, hydraulic excavator. The purpose is for general excavation and trenching work. Bulldozer is to clear and make a level and grade the site. For backhoe loaders, do used to for versatile tasks involving digging, loading, and transporting materials. And for the dump trucks, is used to transport excavated soil and construction materials to and from the site. The compaction and foundation equipment to ensure ground stability and proper compaction. The tools and equipment that have been used is vibratory rollers and compactors. These tools and equipment can help to compacting fill material to the required strength. Next one is piling rigs and rotary drilling machines. It is helps to do is an essential for deep foundation work, especially in weak or waterlogged soils typical of the area. For the concrete work and structural elements, the tools and equipment that have been used is concrete mixers and pumps, which which generally used to mix and place concrete. The next one is bridge abutments and decks will be cast in place and to helps to strong the integration with the foundation. For the surveying and alignment tools, total stations and GPS instruments have been used. And for the safety and operation integrity, throughout the project, it is critical that all machinery and tools need to be adhere to international and national safety standards and full with compliance with Construction Industry Development Board CIDB 2020 and Department of Occupational Safety and Health DOSH regulations. This thing can help to ensure worker safety and equipment reliability are top priorities during the entire construction process. The next slide is I will explain about earthwork construction techniques that have been used in this project. So the first stage is site clearing and grubbing. The objective of this stage is to removing vegetation, topsoil, and organic matter, include eliminating any materials that compromise to the foundation strength. For the second stage is excavation to stable subgrade. The goal is to reach a stable subgrade. This is because under the JKR standard specification for road works, JKR SPJ 2008, all unsuitable material must be replaced with approved fill materials and meeting specific gradation and compaction standards. For the third stage is embankment construction and compaction. After excavation, embankment construction need to be covered because of it can help to well graded sand or gravel is used as a fill material and the fill is will be covered with horizontal layers and the tools that need to be used is vibratory rollers to cover the compaction works. The ground improvement techniques, if required, in areas with very weak soils, ground improvement methods are considered, such as preloading with vertical drains, stone column, and geotextile reinforcement. This method enhanced to the shear strength and settlement resistance. So, for from this project, our group have identified there are four problems on this project, but we also already give a solution to counter these problems. So, the first problem is soft and weak subsoil conditions. For the issue, the construction site, like I mentioned before, lies on alluvial floodplain soil, mostly soft clay, silt, and organic matter. These have low bearing capacity, which can cause excessive settlement and foundation instability. For the solution, um, maybe the contractor can implement deep foundation system such as board piles or driven pile to transfer loads to more deeper and more stable strata. And contractor also can use ground improvement techniques such as preloading with prefabricated vertical drains and stone columns to speed consolidation and improve soil strength. The second problem is flooding and high water table. The issue is the site is prone to seasonal flooding, especially during monsoon season. This poses several risks, such as delays in construction, damage to temporary structures, and compromised field compaction quality. For the solution, contractor may be to develop a comprehensive flood control and stormwater management plan, including temporary diversion channel, comfort dams for safe substructure construction, and drainage system. For the third problem is limited site access and transport logistics. For the issue, the site is in a semi-rural area with narrow village roads and weak transportation networks. So it it making difficult to deliver materials and operate heavy equipment. This can result in delays, traffic congestion, and safety hazards for local residents. For the solution, contractors need to prepare a logistic plan before construction begins, including temporary widening of access roads, scheduling deliveries during off-peak hours, and the last one, coordination with local authorities. For the last problem is environmental and community impact. The issue is bridge construction near to the rivers and villages can cause the pollution, noise disturbance, disruption of ecosystem, and impact on community well-being and water sources. For the solutions, contractor can implement a robust environmental management plan that includes sediment control barriers, noise reducing equipment, and water quality monitoring.
Hello, my name is Thompson Jeffrey Edward, and I will explain on the earthworks carried out for the school project in SK Batu Tiningkang, Tenong. This project involved the reconstruction of a dilapidated school under the Daif Sabah program, with a contract value of 42.35 million ringgits and a duration of 30 months. It was part of a federal initiative to upgrade rural schools in Sabah, with over 230 schools completed as of May 2025. The soil on this project um, was tropical residual soil with a high iron oxide content. It was known locally as Tanah Kuning. This soil type has medium plasticity and low permeability, but it is sensitive to moisture, especially in high rainfall areas like Tenom. Because of the soil isn't uniform, the team had to manage weak spots carefully during earthworks. The earthwork, the scope of earthwork involved was site clearing, bulk excavation, backfilling, and leveling. The existing terrain was hilly and uneven. Uh, Meanwhile, the original access road was too narrow for heavy machinery. To resolve this, the construction team built a temporary access road. The cut and fill excavation method was used, where soil from higher ground was cut and used to fill lower areas. This helps to create a level platform for the building. Now I will explain on how the works was executed on site, the techniques used, and the challenges faced. For this project, the earthworks was carried out using hydraulic excavators, wheel loaders, compactors, and 10-ton lorries. These machines were selected because they were well suited for the cohesive and slightly cemented type of soil found at the site. Excavators used to cut and remove soil, which was then transported by the lorries. Wheel loaders spread the soil at field areas, and compactors were used to compress the soil in layers, ensuring it reached the required density. In certain weak areas, lime stabilizers were applied to improve soil strength and reduce moisture sensitivity. This site adopted the cut and fill excavation method, which is efficient for transforming uneven slope terrain into a level platform. This involved cutting soil from a higher ground and filling lower areas using excavated material. Firstly, a topographic survey was done to plan out the cut and fill zones. Topsoil containing organic material was then removed since it was not suitable for structural support. Excavated soil are then transported and placed in fill areas in around 100 to 300 millimeter layers. Afterwards, each layer is compacted before adding the next. A temporary drain was also installed around the site to prevent soil erosion from surface water. This project faced two main challenges. First was the frequent rainfall in Tenom, which caused delays as wet soil turned muddy. making it unsuitable for compaction. The team handled this by waiting for the soil to dry and then working overtime, sometimes up to 12 hours a day to catch up on lost progress. Second issue was the narrow and slope access road. This made it dangerous for heavy machinery and material delivery to go through. To solve this, the team widened the road by filling and compacting the sides, spreading gravel to improve conditions during rain, and also installed signboards and cones to improve site safety.
So we'll talk about the common issues in earthwork operations. One of the most pervasive challenges in earthwork is soft and weak subsurface conditions. For example, sites located at alluvial floodplains often consist of unstable layers, clay, slate, and organic materials. These materials have low bearing capacity, increasing the risk of settlement and structural failure. To mitigate this, engineers must conduct through geotechnical investigations and consider solutions like soil stabilization or deep foundations. Next, high water table and seasonal flooding pose significant risks. Excess water can delay timelines and compromise the quality of compacted fill, leading to long-term instability. Proactive measures such as dewatering system, proper drainage design, and seasonal planning are essential to keep projects on track and ensure soil integrity. Next is logistical challenges. It is like restricted site access or narrow village roads that can hinder equipment movement and material transport. This escalate costs and delays. Early route service, community coordination, and phased deliveries are practical strategies to minimize disruption. Lastly, environmental and community concerns cannot be overlooked. Earthwork often generates noise, water pollution, and ecological disruption, leading to regulatory or public backlash. Adopting best practices like silk fence, noise barriers, and stakeholder engagement helps align projects with sustainability goals and social license to operate. Now I will talk about the solutions implemented and their effectiveness. Soft soils, such as those found in alluvial floodplains, require robust engineering solutions. Two primary approaches have proven effective. Firstly is deep foundation systems. Techniques like driven piles and bored piles transfer structural loads to stable strata, mitigating settlement risk. Ground improvement. Methods such as freeloading, vertical drains, and stone columns enhance soil strength and accelerate consolidation. For flooding, firstly is stormwater and flood control. Installing cofferdams and culverts diverts excess water, protecting the work area. Other than that is dewatering systems. Temporarily lowering the water table ensures dry conditions for compaction. Next is for logistics. Firstly is temporary road widening, facilitating equipment movement in confined areas. Next is precast modular components, reducing on-site and transport frequency. Last but not least, for environment and the community. Environmental management plans help in erosion control, noise reduction, and pollution monitoring. And public engagement helps in regular updates and grievance redressals, fostered community trust.
So for the comparative analysis review, we're gonna compare two projects, which is Project A and Project B. So the main focus for this comparative analysis review are the earthwork practices, effectiveness and efficiency, and the cost and environmental performance. So the purpose for the comparative analysis review are to identify the similarities, differences, and outcomes based on each project's early construction activities. So for 6.1, which is the earthwork practices, so there are four criteria from each project. So the types of criteria are the site clearing, the excavation, the temporary access, and the machinery used from each project. So the summary, project A had more difficult terrain
and water-related challenges, while the Project B had wider but simpler earthwork. So for 6.2 are the effectiveness and the efficiency. So from both from each project, we are going to compare the progress, the site challenges, the QA or QC measures, and the adaptability. So to summarize, Project A moved faster despite difficult conditions, while Project B worked smoothly but lacked details record in the project. So 6.3 are the last comparative analysis review. So which are the cost and environmental impact. So we're going to compare from each project the contract sum, the fuel use and emissions, the environmental measures, and the risk level for each project. So to be summarized from the table, Project B cost more overall, but Project A had more environmental risk and pollution due to its riverside location.
So now I will talk about the summary. For the challenges, such as soft soil, unstable ground conditions required innovative stabilization techniques. For flooding, waterlogged sites disrupted timeline and demanded adaptive solutions. For logistics, complex supply chains and material transport added layers of difficulty. For environmental concerns, balancing progress with ecological preservation was critical. For the success, engineering solutions is the first one. So, custom design and technologies address soil and water issues head on. For the planning, proactive schedule and risk management kept on track. And for standards, rigorous quality control ensured safety and compliance. Lastly is the key geotechnical expertise. Thorough site analysis is non negotiable for stability and safety. Water management, robust systems are essential to mitigate flooding and ensure continuity. For community involvement, engaging stakeholders early fosters trust and smoother execution. First, I will talk about the recommendations for future projects. So, firstly, thorough geotechnical surveys. They mitigate risks like soil instability or unforeseen ground conditions. Second is investing in comprehensive surveys upfront save time, cost, and reputational damage later. Next is the robust water management systems. Implement systems for damage flood control and water reuse. This reduces downtime during extreme weather and aligns with sustainability goals. A dry site is a productive site. Next is a precast or modular construction. To accelerate timelines and improve quality, we recommend precast or modular constructions. Fast control production reduces errors and waste. Faster assembly on site means earlier project delivery. Next is the environmental and social focus. Projects must balance progress with responsibility. Environmental management plans ensure compliance and minimize ecological impact. Community engagement builds trust and secures social license to operate. Next is leverage technology, which is use of technology. Tools like GPS and total stations improve accuracy and reduce rework. Digital workflows enhance collaboration and data-driven decision. So now is the conclusion. Our first case study involves the Manaik Taraf Jambatan Sungai Moyok Bridge, which faced three major challenges. Soft soil that required deep foundations and soil stabilization techniques. Second is flooding, demanded robust water management systems to protect the structure. Third is accessibility issues, complicated logistics, and material transport. For the second case study for SK Batu Tiningkang School Redevelopment, there are residual soils prone to erosion, necessitating slope stabilization measures. And second is heavy rainfall. It required advanced drainage systems to prevent water damage. So the lesson learned and the best practice are this project highlight universal lessons for resident construction. such as adherence to standards. Compliance with JKR, CIDB, DID, and DOE guidelines ensure quality and safety. Second is the tailored solution. Site-specific strategies like deep foundations or slope control are non-negotiable. Thirdly is the proactive risk management. Flood mitigation and soil testing must precede construction. Sustainability and technology, leveraging eco-friendly practice and tools. For example, GIS or sensors enhance efficiency.